problem right here. Here this question is asking us to find out this IA current, IB current, and IC current. We have the current source and these resistors are provided. Now let's see how we can solve for this. First of all, we know that we have a one voltage provider, that is Vx. This is the only one provided. This is the voltage dependent current source. So this is not a voltage. This is the only voltage provided right here. And you can see the resistors are parallel. So the voltage across the resistor is going to be exactly same as Vx, because whenever we have a parallel circuit, the voltage across the parallel circuit is going to be equal everywhere. So the voltage across this resistor is going to be Vx as well. So that's one thing we have to note down. I'm going to note down right here. Parallel, same voltage. Okay. Now let's assume we connect this bottom to the ground. Okay, we connect the bottom to the ground. So if we connect that one, then we only have one node right here. That is the top part. This is the only node right here. And if you are talking about node, we are talking about Kirchhoff's current law. Kirchhoff's current law says that whatever the node, if you add all the current entering and existing the node, that's going to be equivalent to 0. Or you can say Kirchhoff's current law can be said as, Kirchhoff's current law also says that whatever the currents go is in is equivalent to whatever the currents goes out. Both of them are same, like or addition of all the currents is equal to 0, or sum of current in is equal to sum of current out. Now we are going to use sum of current in and sum of, that's equal to sum of current out. So let's apply KCl. KCl at the node, let's call this one node 1. At node 1, sum of current in is equivalent to sum of current out. Now let's see what are the currents that's going toward the node. We have 5.6 ampere that's going toward the node, so that's going to be this side, 5.6 ampere. And then we have 0.1 Vx that is going into the node, so that's going to be here as well, 0.1 Vx. And what are the currents going out of the node? So these are the only two currents that's going in the node. What are the currents going out of the node? IA is going out of the node. And IB, I don't put IB because IB is equivalent to negative, like IB is exact same current as 0.1 Vx, that is just opposite side. So IB is equivalent to negative 0.1 Vx. We already used that one right here, so we don't write the IB again. So we leave that one alone. And IC is getting out of the node, so that's going to be here. And then 2 ampere also getting out of the node, so that's going to be here as well. And here if you see, we have a lot of unknown variables, like we have Vx unknown, IA unknown, IC unknown. We have 3 unknown variables. Now to simplify this one, and to make into one unknown variable, what we can do is we can apply Ohm's law. Ohm's law says that V is equal to I times R. And here we have resistor, we have 18 ohm resistor, 9 ohm resistor, and we know that voltage across the voltage across this circuit is going to be same, since this is a parallel circuit. So the voltage across this 18 ohm is going to be Vx, and also the voltage across this 9 ohm also going to be Vx. So if we apply Kirchhoff's, if we apply Ohm's law here, IA is going to be what? If we rearrange this equation, V is equal to IR, therefore I is going to be equal to V divided by R. So the voltage here is Vx. That one divided by the resistor, that's 18. So IA is going to be Vx divided by 18. And IC, that's going to be equal to Vx again divided by 9. So we express this IA and IC in terms of Vx. Now we can go ahead and plug it in this equation and let's see what happens. 5.6 plus 0.1 Vx, and then instead of IA I plug Vx over 18, and then we have IC, instead of IC I plug Vx divided by 9 and then plus 2. Okay, so here you can see we only have one unknown variable. So if we find the Vx, then we can substitute Vx in this equation and solve for Ia, and we can solve for IC. Once we have, so also we know that IB is also related to Vx. So if we find Vx, we can find everything. Now let's go ahead and solve for Vx. And here you can see in Vx denominator we have 18. To get rid of this denominator, I can multiply both sides by 18. If I do that, 18 times 5.6. If you multiply, you're going to get 100.8, and then plus 0.1 times 18, that's 1.8. Vx over 18 times 18, 18 cancels, so we get Vx, and Vx over 9 times 18, that's plus 2Vx, and then plus 2 times 18, that is going to be 36. Okay, now let's add the like terms. Let's bring all the Vx to the one side and bring the numbers to the other side. So here we have 3 Vx here, and if I subtract this 1.8 from that, that's going to be 1.2 Vx, and if I bring this 36 to the other side, that's going to be 100.8 minus 36, that's going to be 64.8. And if you solve for the Vx, you're going to get 54. Okay, now we have the Vx value. So once we find out the Vx voltage, we can solve for this current and find each of them. Let's apply for the Ia. Ia is going to be equal to 54 divided by 18. 18 times 3 is 54. So this is 3 ampere. And then this is one of the answer. We found out the Ia. Now let's look at the IB. IB is basically negative 0.1 times Vx. We know Vx is 54, so if you multiply, it's going to be negative 5.4 voltage, 5.4 ampere. And for the third one, so this is IB. We found out the IB. The last one we had to find is IC. IC is Vx over 9. IC is equal to Vx over 9. Vx is 54 divided by 9. That's 9 times 6 is 54, I think. Yeah, 9 times 6 is 54. So IC is going to be 6 ampere. Wait a minute. Yes, IC is equal to 6 ampere. So we found out IA is equal to 3 ampere, IB is equal to negative 5.4 ampere, IC is equal to 6 ampere. That's what we wanted to find, and that's it. I hope you guys find this video helpful. Thanks for watching, and don't forget to subscribe my channel. See you guys on my next video.